Hello everyone, welcome to PyNet Labs. My name is Chirag, and in this video today we are trying to understand how the CCIE Enterprise Infrastructure training works at PyNet Labs. So let me explain you what exactly we are going to talk about in this upcoming training, how we'll be performing our labs, and what exactly you can expect from the training. Then also we'll have a look on understanding DMVPN today. Let's get started. Let's see what we have got to cover.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So guys, when we talk about the official content of CCIE Enterprise Infrastructure, it contains a lot of things. It contains a lot of understanding on various aspects of networking. If I majorly categorize it, so mostly it is about routing and switching. Then you get to know about SDN technologies, where you learn about SD-WAN. Then you learn about SD access. Finally, you talk about automation and programmability. The routing and switching definitely includes many other things like network services, security concepts, and so on. The complete outline of CCIE is available on the official website of Cisco. We will put the link in the description about the content that you can explore. Then when we talk about the training that we'll be having here at PyNet Labs for this CCIE program, the training will include 5 modules. So let's try to understand this. There are going to be 5 different modules helping you in preparing for all the topics that you should be aware of to appear for your CCIE lab exam. In this 5 module, the module number 1 is going to train you on core networking concepts. So you will be learning here about layer 2 operations. You will learn about layer 3 operations, basics of routing protocol like EIGRP, OSPF, BGP, then how multicasting works, then some basic routing concepts like VRF, redistribution, authentications, such things. Then we get to see the module number 2, which helps you in exploring the depth of networking. The module number 2 will help you understand the concepts that you learn in module number 1. First of all, those concepts a little more in depth and detail. Then also some additional topics that you should be aware of to get deeper into the concepts of networking. The module number 1, like I explained, will help you in understanding the basics, will prepare you to get started with the program. It's more of, you can say, the content that you get to learn in the ENCOR program. But the module number 2 is something more advanced. So here you will get the advanced knowledge of networking. Here we'll be talking about all the routing protocols, their metrics, their operations, their features. For example, if I be specific to, let's say, EIGRP, then we will understand how EIGRP adjacency works, what are the best path selection criteria, what is feasibility condition, how the calculations are done, then what is stuck inactive, how graceful shutdown can be configured, what is EIGRP named mode, what is leak map, what is summary routes, what is chub routing, and so on. Same applies for OSPF. You get to learn about some advanced features like SPF tuning. You learn about graceful shutdown here as well, different types of areas, different types of LSAs. And then same applies for BGP, multicasting, and the routing concepts. So in routing concepts, you can expect the knowledge on BFD, again, route filtering, how VRF leaking works, all such concepts. So a detailed description on all of these module breakup is given in the description. So you can go there and check this whole content and you can find that, okay, what module covers what all topics in that particular file. Other than these things, in the module number 2, we'll be talking about things like QoS. We'll talk about private ACLs, then VLAN ACLs, URPF, then security concepts like I mentioned, URPF, DHCP guard, all such things. Then we'll also talk about transport technologies in this particular module, which is again an important part where we talk and learn about things like DMVPN, then MPLS, how NHRP protocol works, how exchange happens, how the tunnels are created. So whatever you need to know to work on a complex and enterprise network, you will be trained on that in the module number 2. The module number 3 explains the SD-WAN technology. Here we'll learn from the very basics that what is the operations of control plane, data plane, then how controllers are, you can say deployed, how WAN edges are onboarded, how the templates are created, how VPNs are created, how the internet breakouts are applied. So all such things will cover in the Cisco SD-WAN segment, which is the module number 3. Then the next module, module number 4, is about Cisco SG Access, where we get to learn about the controller DNAC in detail. Here also, we'll be learning first through the basics. First, we'll understand the underlay, we'll understand the manual configurations, the device discoveries, the policies that we can apply in the underlay. Then we will talk about the overlay configuration, where we learn about different types of policies, different types of, you can say, data plane related configurations that we can deploy through the DNAC. Then how the fabric designing works, how the deployment works, single site, multi-site configuration, then border priority, how the devices can be added, how the authentication can be done, all such things. So these are few, you can say, some of the major topics that we cover under the Cisco SG Access. Definitely, there are some more subtopics which can be explored in the content. So again, you have the file there in the description. You can look through. Lastly, the module number 5 is about automation and programmability. Here you will get a detailed understanding on how Python works, how APIs work, how model-driven programmability protocols like RESTconf, NetConf works, how the HTTP requests are created, then what are the Python libraries that can be used in network automation, how the controllers like DNA Center or vManager can be configured or can be managed using APIs. So such understanding would be provided to you in the category automation and programmability. Now talking about the lab part. So we'll be performing labs with some small topologies, and then we'll combine them together to bring up a connection or to bring up a scenario which is going to help us in preparing for the lab attempt. So initially, we'll keep the simple connectivities. We'll take single branch. We'll take a couple of devices there. We'll test out our configuration. Let's say maybe some IGP configuration. I'll test out my OSPF here, for example, and that's my branch number 1. Then there's going to be a data center where I'll have, let's say, my some WAN edges, then some layer 3 devices, maybe connected like this. Then some SD-WAN components like the vManager, the vSmart, the vBond. Then somewhere here, I'll have my DNA center. So such kind of establishment of topology would be there by the classes, or we can say gradually we'll be working on this through the modules, through the concepts that we cover. So we'll keep on building the small chunks of these topology, and we'll build up together to create a complex scenario where there's going to be a DC side, there's going to be 3 to 4 branches, then there's going to be, let's say, some component where I have the DHCP server running on a particular cloud setup. So I'll create such a big and complex scenario that can help me in practicing all the concepts and all the CCI related topics that we will learn while reaching that level, or you can say that we will be learning throughout this training. And at the end, when we will work on this complex topology. We'll test out these understandings and knowledge on this complex topology. We will be able to appear for the exam, or you can say you will get you'll get ready for appearing for your attempt to get the CCI number. That's going to be the approach of our training. Now, in the session today, we are going to talk about one of the very important protocol, or you can say a topic that we get to see in the configuration of CCIE, which is DMVPN. So let's try learning about it a little bit. Let's try to understand the protocol, and let's do a lab related to it to see how things will work in the classes as well. Yeah. So let's first of all understand what is DMVPN. DMVPN stands for Dynamic Multi-Point VPN. It's a routing technique that we can use for building VPN between multiple sites without having to configure static tunnels. Let's say you have one site here, then one site here, and one site here, and all of them are connected through internet. So if I want to bring up connectivity between them, I need to create some overlay tunnels, right? I need to have an overlay connectivity with my sites like this. Now, instead of performing the manual configuration of this site-to-site tunnels, what we do is we use a dynamic protocol called DMVPN, which dynamically creates these multi-point VPNs. To understand the DMVPN, there are, we can say, 3 important things that we are supposed to learn about. The first one is multi-point GRE. GRE is the generic routing encapsulation protocol that we use for the regular tunnels, where we simply create a connectivity between two of our remote branches. So that when is done on a multi-point basis, we call it multi-point GRE, or popularly known as MGRE. So that's the first thing that you need to be aware of. Second thing is the protocol NHRP. NHRP stands for Next Hop Resolution Protocol. And the third thing, the final thing, is the routing protocols. So you need to know how routing protocols work, like RIP, EIGRP, OSPF, or BGP. If you are aware of these things, you are good to proceed with the DMVPN configuration. In the session today, I'll give you some explanation on that so that I can make you learn about this concept DMVPN. When I talk about the first point, which is multi-point GRE, it is basically a concept where tunnels are created from one point to multiple destinations. I'll explain you how it works. Now, in a usual scenario, like I explained, this is going to be my internet. This is going to be my, let's say, branch number 1, branch number 2. Then maybe this is my headquarter branch. So I would like to use this public interface that I have on the headquarter branch to create a tunnel with my site number 1 as well as site number 2, correct? Similarly, if let's say there are some more branches, branch number 3, 4, 5. So I would like to use the same physical interface for creating tunnels with all these other branches. Because if I want a connectivity with all of them to accomplish a successful connection with all the branches, I need to have a reachability from one router to all the other sites, right? And for that, I would require a tunnel interface. Now, if I have 4 or 5 branches and I create 5 tunnel interface on my headquarter branch, then things will get messy very quickly. So instead of creating 5 tunnel interfaces, what I do is I create one interface and I allow it to create tunnels with multiple destinations. And that is simply your MGRE, multi-point GRE. So as the name implies, it will allow us to have multiple destinations. And when we use these destination addresses, we can create tunnels from one point to multiple destinations. So you can see your tunnels will look something like this. One point from the headquarter site, but from there it can go to multiple sites, branch 3, branch 4, or whatever number of branches you have. That's how the tunnel will be created through MGRE. This type of connectivity is something that we use with DMVPN. Now, there are different phases of DMVPN. We'll talk about that later. As of now, let's talk about the next part, which is NHRP protocol. So NHRP, that stands for Next Hop Resolution Protocol. It helps us in figuring out the public IP address of the other sites. So for example, if I want to send some traffic from branch number 1 to branch number 2, so what I will do is I will use NHRP protocol to get the IP of branch number 2 from my headquarter branch. So in my this communication, headquarter branch will be treated as hub and these two branches will be treated as spoke. So to get the public IP of my spoke 2, I will go to my hub and I'll ask for the IP address. And I do that using the protocol NHRP, that is Next Hop Resolution Protocol. So let's understand it again in a deeper sense. In this communication, one router is going to be my NHRP server and all the other routers will be known as my NHRP clients. First step is that the NHRP clients will register themselves to NHRP server. So they'll go to NHRP server, they'll tell about themselves and they'll say that, okay, this is my public IP address. Now what NHRP server does, it keeps a track of all that information. So step number 2 is you can say NHRP server will store this information, store this info in its cache. As simple as that. Now, if my spoke 1 wants to communicate to spoke 2, so what it will do, it will directly go to the NHRP server and will ask for the public IP of spoke 2. That's how it works. So now basically R1, or you can say spoke 1, will go to the hub site, will ask for the public IP of spoke 2. Once it gets that public IP, it will basically send the packet or the information to the spoke 2. Just like that, if let's say there are some other sites, let's say there is multiple other sites. So what will happen if they want to speak to one of the site? So they'll first get the public IP from the hub using NHRP and hub will provide them the public IP. Then the spoke can directly speak to the spoke 2 like that. So initially we require a connection with the hub site and then After we get the information about the public IP of the spokes, the other spokes, then I can use that information to even create tunnels between my spoke sites so that I don't have to get to the hub site every time. So I can directly speak from spoke 1 to spoke 2 or spoke 1 to spoke 3, spoke 1 to spoke 4, like that. Now, this depends upon the type of configuration that you deploy. But yeah, this is the overview of how NHRP operates. Now, there are few things to keep in mind that the underlay connectivity is must. What is underlay connectivity? The physical links. So this connectivity that you have, it should be up. If you want the overlay connectivity to be up, that's the basic logic of tunneling, right? The underlay network should be up. The connectivity should be there between the routers over the internet, for example. And then over that, a overlay network is created through tunnels of GRE, MGR. That's how it works. Now, DMVPN, like I explained, has three different phases. There is phase one that allows communication between hub to spoke only. So a communication between hub to spoke is only allowed. So for example, if I want to send some traffic from spoke 1 to spoke 2, it has to pass through the hub. That's your phase one. Then phase two gives you the ability of creating spoke to spoke tunnels with following requirements. The first requirement is that your spoke need to have a route to the network they are trying to reach. They are trying to reach. And the second requirement says the next hop IP of that route should be remote spoke. So let's understand what exactly this means. For example, this is my hub site and this is my spoke 1. This is my spoke 2. If I want to send some traffic from the LAN of spoke 1 to LAN of spoke 2. So let's say I want to send some traffic from spoke 1 to the LAN of spoke 2. So I need to have a dedicated route, a specific route to the network that I am trying to reach. And the next hop of that particular network should be spoke 2 only. So when we talk about default routes or when we talk about some other policies that can allow such communications, they won't work in phase two. No, phase two requires these two things to be followed. And then there is phase three, which is the best one because that has no such requirements. Phase three is there, which is again something that allows the spoke to spoke communication. And there are no such requirements where you don't have to have any route. So basically you can say all spokes will be using connectivity. The spoke to spoke connectivity would be there. And there is no requirement of, you can say, any route or any route having a particular next hop IP address. No such requirements are there. So the spoke routers no longer need a specific route to reach the remote spokes. And also it doesn't matter what is your next hop. So whatever conditions are there in phase 2, they are not there in phase 3. The phase 3 allows you to work freely with it. In the lab today, we'll be observing how the phase 3 communication works and how the configurations for DMVPN phase 3 can be done. I'll give you the difference between the phase 2 and phase 3 configurations, and we'll explain you how they are different basically. So let's see, we will create a configuration on a similar topology where I have a single hub and multiple spokes. So let's see how that configuration work. I'll quickly share my other screen. And yeah, I mean, we missed on one point, that is the routing protocols. So routing protocols, you should be aware of these routing protocols, how they work, how the configuration of these routing protocols are something that can be done so that you can advertise your LAN routes over a routing protocol like EIGRP or OSPF or whatever you are using, right? So that configuration or that understanding of the routing protocol is also required. Now let's jump on to the lab part. I'll share my other screen. I have kept a small lab ready for the configuration. So this is a similar example of to what we discussed. Here we have a hub site, which is available on the IP 10.100.1.1. Then there are three spoke sites that can be reached on the IP 10.100.1.2, 1.3, and 1.4. In between, I have given a switch that is working like internet for me. Now, the loopbacks are going to be there. The loopback of hub site is going to be 1111. The loopback of spoke 1 will be 2.2.2.2. Then similarly 3333 for spoke 2 and 4444 for spoke 3. And then the tunnel configurations will be done on the network 192.168.1.0. So let's get started. Let's see how this configuration works. And let's try understanding the meaning of commands that we push in the configuration to enable DMVPN phase 3 configs. I'll jump onto my hub site first of all. If I show you here, show IP interface brief. So we have this IP on gig 00, and then this is the loopback 0. Here I'll create a tunnel interface by saying interface tunnel 0. I'll set the IP address on it from the subnet 192.168.1.0. So I'm going to say 192.168.1.1/24, and we are done. Then we specify IP-NHRP authentication command. Here you can give a string that will be used for authentication. So basically, this is not a, you can say, mandatory command, it's optional, but a good idea to enable, right? So I'm using the pre-shared key PyNet in this case by specifying the command IP-NHRP authentication PyNet. After that, I'll say IP-NHRP map multicast dynamic. Now, what is this command? So IP-NHRP map multicast dynamic, this command tells the hub router where to forward the multicast packets. Now, because there are going to be multiple destinations, there's going to be spoke 1, spoke 2, spoke 3. So we have left the decision of forwarding or finding out the destination IP dynamically or automatically on the protocol NHRP. So we are saying that to send the multicast traffic, you have to dynamically learn about the destination IP addresses. Next command is about network ID. So IP NHRP network ID 1. Now, what is network ID? Network ID is used for, you can say, differentiating between two networks. This is locally significant. And sometimes when you troubleshoot your problems, a good approach is to keep the same values on all the devices. So if you have the same value on all the devices while troubleshooting, you won't find it very difficult to understand the same networks, right? So IP NHRP network ID 1. I'll use the same on the spokes as well. After that, we'll specify the source of my tunnel. So that's going to be tunnel source GI0/0. And then I'll specify the mode of my tunnel as multi-point GRE. So tunnel mode GRE multi-point. Now, since it is multi-point, we don't have a specific destination to specify. So we'll just specify the source and then we'll create the mode, or we can say we'll set the mode to MGI. Lastly, the command that enables the phase 3 of my DMVPN is IP NHRP redirect. If I don't use this command, then I can say I am limiting my configuration up to the phase 2. But if I add this additional command IP NHRP redirect, that enables the phase 3 configuration of my DMVPN. Let's try understanding what exactly it does. IP NHRP redirect command on the hub device will tell the spoke routers that they can speak to each other through a direct tunnel. That's basically the responsibility of the command IP NHRP redirect. And with this, we are done with the configuration of my hub router. Let's move ahead. Let's configure the spoke devices one by one. Let me take the access of spoke 1. Here also, if I show you show IP interface brief, this is the public IP, this is the loopback IP. Config T interface tunnel 0. IP address is going to be 192.168.1.2/24 subnet. IP NHRP authentication through the keyword PyNet. Then IP NHRP map. And if you put a question mark here, we have to specify the IP address of destination. So what's my destination? 192.168.1.1. Again, question mark. Talking about the NBMA address. What is NBMA address? In simple language, NBMA is going to work as your public IP. So whenever you see NBMA address, just understand you have to put the public IP. So I'll put the public IP 10.100.1.1. Now let's try to understand this command. When I say IP NHRP map, so basically I am creating a static mapping and I'm telling my spoke router that to reach the destination 192.168.1.1, the public IP that can be used is 10.100.1.1. After that, I'll specify the multicast traffic destination. So IP NHRP map multicast, and I'll use the public IP of my server again, or the hub again, which is 10.100.1.1. So using this command, you are specifying the destination where the multicast traffic should be sent through the tunnel interface. After that, we'll specify the network ID, just like we did in the case of hub router by saying IP NHRP network ID 1. Then I'll specify the next hop server, IP NHRP NHS, next hop server, and then we have to put the protocol IP. Protocol IP means the tunnel IP. NBMA IP means the public IP, as simple as that. So IP NHRP NHS 192.168.1.1. Then I'll again specify the tunnel source as GI0/0, and the tunnel mode is going to be GRE multipoint. Finally, the additional command that converts my phase 2 into phase 3 is IP NHRP shortcut. Now, this particular command that we use on the spoke devices, this basically enables the phase 3 configuration. So you can say when you enable this command, the spoke routers will be allowed to make changes in the CEF entry when they receive a redirect message from the hub. So whenever they'll receive some information about the public IP of other spokes, they'll be allowed to make changes in the next hop details so that they can directly send the traffic from spoke 1 to spoke 2 instead of spoke 1 to hub and then hub to spoke 2. That's how it works. So basically, this is the additional command that you need to run on the spoke devices. And we are done with this. Now I can jump on to the next spoke, spoke number 2, and we can start configuring the tunnel interface there. So config T, interface tunnel 0, IP address 192.168.1.3. Sorry, 1.3, 255.255.255.0, IP NHRP authentication PyNet, then IP NHRP map 192.168.1.1 with the public IP 10.100.1.1. Then IP NHRP map multicast with 10.100.1.1. Then IP NHRP network ID is going to be 1. IP NHRP shortcut for enabling the phase 3. Then IP NHRP NHS next hop server. That's going to be my protocol IP or the tunnel IP 192.168.1.1. Finally, tunnel source GI0/0. Tunnel mode is going to be GRE multipoint. And we are done. Lastly, I'll jump onto the spoke 3 and put the configurations there. Interface tunnel 0 IP address 192.168.1.4/24 subnet. IP NHRP authentication with the string PyNet. IP NHRP map 192.168.1.1 with the public IP 10.100.1.1. IP NHRP map multicast with 10.100.1.1. Then IP, what else? NHRP network ID. After that, IP NHRP next hop server 192.168.1.1 and IP NHRP shortcut. Then tunnel source. That's going to be GI0/0. Tunnel mode is going to be GRE multipoint. And we are done with all the configs. Now, after doing this much of configuration, these 3 spoke devices will register themselves to the hub device. And we can check that information by running the command show IP NHRP. And you can see here we have got 3 registrations for 192.168.1.2, which is reachable on the NVMe address 10.100.1.2. Then 1.3, 10.100.1.3, 1.4, and 10.100.1.4. That's basically how the information will be stored in the NHRP cache of next hop server, the hub device. Now, if I go and try connectivity between hub to the sites, if I say ping 3.3.3.3, do we have a reachability? No. Why? Because the routes are not getting exchanged. So on top of these tunnels, I will run EIGRP to make them learn about each other's route. So let's configure EIGRP, and in the EIGRP configs, we will advertise the tunnel interface as well as the loopback interface. Let's start it from hub device itself. Config T router EIGRP 10, no auto summary, network 1.1.1.1 with a wildcard mask of 0000. Then network 192.168.1.0 with a wildcard mask of 000255. And we are done. Then I'll go to my spoke device, router EIGRP 10, no auto summary, network 2.2.2.2, and network 192.168.1.0 The EIGRP neighborship is up. Perfect. Let's move to the next device, spoke 2. Router EIGRP 10, no auto summary, network 3.3.3.3.0.0.0, and network 192.168.3.0.255. Oops, I made the mistake there. That's why the EIGRP neighborship is not up. Router EIGRP 10, no network 192.168.3.0. And it should be network 192.168.1.0 with 0.0.0.255 as the wildcard marks. The neighborship is up. Perfect. Let's jump on to the next device, spoke 3. Router EIGRP 10, no auto summary, network 4.4.4.4, and then network 192.168.1.0.0.0.255. Neighborship is up. Now I'll go and check my EIGRP routes. Show IP route EIGRP. Okay, I made the mistake there. Let me try terminating this. Yeah. So if I check show IP route EIGRP, I can see I have received the route for 2222, 3.3.3.3 and 4.4.4.4. Perfect, right? Similarly, if I go and check it on router one, let's say, I'm in the spoke one, let's say. So let's see what do we get. Show IP route EIGRP. Okay, we are just receiving one route, that is 1.1.1.1. We are not receiving any information about the other spoke routes like 3.3.3.3 or 4.4.4.4. Let's understand why. So what's happening basically, Hub is learning about 3.3.3.3 and 4.4.4.4 on the tunnel interface, right? And because of split horizon, EIGRP won't allow the advertisement of 3.3.3.3 and 4.4.4.4 out of the tunnel interface. So what happens basically, the information that I receive on tunnel 0, I can't send it out back to spoke 1 or to spoke 2 or spoke 3 on the same particular interface. So now there are two solutions. One solution is that I disable the split horizon feature of EIGRP. And the second solution is that I deploy a default route from the spoke to the hub. So what I'll do is I will go for the default route. So I'm going to advertise a default route from my hub site to the spoke site, which will point towards the hub as the next hop. So let's do that. I'll go back to my hub. I'm going to get into the tunnel mode, interface tunnel 0. And here I'll say IP summary address. We have the protocol EIGRP. So IP summary address EIGRP, autonomous system number 10. So I'll put the summary network 0.0.0.0. And if I put a question mark again, I have to put the network mask, which is again going to be 000 because it's a default route. And we can see the neighborships are refreshed. If I go now on my spoke 1 again, and I check my routing table again, what do I see? I see a default route pointing towards 192.168.1.1. Similarly, on the other spokes also, you will find a default route. Show IP route EIGR 0000. And guys, do you remember I told you the difference between phase 2 configuration and phase 3 configuration? Now, since it is phase 3, the spoke 1 can speak to 3.3.3.3 even without having a dedicated route for that particular destination network. We don't have any specific route for reaching 3.3.3.3, right? We have a default route, and that too has the next hop as hub. But if let's say this was phase 2 of DMVPN, then I would need a specific route of 3.3.3.3 on my spoke 1 with the next hop as spoke 2. Until and unless I will not receive that route, the communication will not happen if it was phase 2. But since it is phase 3, we can use this default route also to make this communication. So let's see. We'll try to trace the packet going to 4.4.4.4 and we'll source it from loopback 0, let's say. See what path it takes. Okay, it has gone to the hub router, which is 192.168.1.1. And then it has came back to the spoke 3, 192.168.1.4. So it has gone from spoke 1 to hub and then hub to spoke 3. But we wanted the spoke to spoke communication, right? So why is it not working? It is working, But when you try it again, so what happens when you send the packet for the very first time, it will go through hub only. But after it has gone through hub, it will learn about the public IP of the spoke and then will try creating a tunnel with the spoke directly. As a result, you can see the traffic is now directly transmitted from spoke 1 to spoke 3. Same applies between spoke 1 and spoke 2 as well. So if I try it for the first time with, let's say, 3.3.3.3, then it might go from hub. But when you do it again, when it must have learned about the public IP. So now when you do it again, it will use the dedicated tunnel from spoke 1 to the spoke 2 for sending configuration or for sending basically the packets. Let's see how it's working. Yeah, there it's going with the hub. Then from hub, it will come back to spoke 2. But when I try it again, so when I try it again, this time it should go directly from spoke 1 to spoke 2. Let's see. There we are. So it has directly gone to 192.168.1.3 without including the hub in the transmission. So yeah, that's how the phase 3 configuration of DMVPN works. I hope you enjoyed the session. You liked the explanation that we have discussed today in this particular video. This was all about DMVPN. There is configuration of OSPF and BGP as well that can be replaced with EIGRP configs here. And the things that we have learned will get a little bit twisted with these other protocols. But yeah, that's something that we'll be covering in detail in our training process. As of now, I just wanted you to have the idea about the protocol and how it works basically. So I hope that that gets delivered through this particular video. So thank you so much again. For all the lab part that we have done so far, you will be receiving some dedicated lab guides like you can see on the screen. This is the exact same scenario. I have prepared such lab guides for all the topics that we cover in the training, for all the labs that we cover. That's been a practice for us at PyNet Labs, be it for this particular CCI training or be it for any other training. So we will be delivering such lab guides to you all so that you can practice and refer to them while making the configurations or while practicing your concepts. So yeah, with that, I hope this gives you a clarity on how the training is going to be about CCIE at PyNet Labs, right? And I am super excited to see you all in the particular training and to work with you all and to get your CCI number with you. So thank you so much again. I hope you enjoyed the video. Take care of yourself, keep learning, and bye-bye.